All right, folks, this is it. The last video from Skill 16. So what we're going to do is look at an example that's almost a little bit more practical. So for instance, say you're driving in a car like you do, and you see a sign, you've got a hill coming up with a 6% grade. And what you can do is you're actually going to drive on it, right? And you can kind of follow your odometer and see that you've driven on it for 4 miles. So in this case, what you're getting here is the measurement of the hypotenuse. You're not really getting the actual sort of directly sort of into the hill horizontal distance, right? You're not a mole man or woman tunneling into the hill. You're driving on top of it. And so you get this you get this hypotenuse, right? Not the horizontal. So you don't directly get a number that relates to the percent grade. And so the question is, well, are we clever enough? Do we have enough sort of trig tools built up that we can go from this hypotenuse distance, this sort of driving distance, and then find how much elevation we've gained, right? So we're trying to sort of figure out if we drove up this hill, we're driving for 4 miles at this particular grade, this 6% grade, how much elevation are we going to gain? So let's see what we can do. So obviously, if we start to sort of label this a little bit, we're talking hypotenuse and we're talking opposite, right? From a SOHCAHTOA perspective, we've got our sort of angle of incline here, which we don't know yet, but maybe we can find that. And if we can find the angle, we can do opposite and hypotenuse. We could do some sine stuff, the SOHCAHTOA. But we've got a few steps to go before we get there. So opposite, hypotenuse. First things first, we could do some conversions. We can sort of convert this. The elevation we'd like in feet, so we'll just go ahead and convert into feet from the beginning. You could do this at the end. You could do it at the beginning. It doesn't particularly matter. So 4 miles, right, times 5,280 feet per mile would get us 21,120 feet. So the actual value here we're working with is going to be that 21,120. So what's next? Well, we can find the angle of elevation, right? We sort of saw in the last video, the last examples. We can connect our percent grade to the angle of elevation, the angle of incline, right? So that formula that we were using is our angle should be the tangent inverse of the percent grade divided by 100%, aka just the percent grade converted into a decimal, right? So 6% would, of course, be 0.06 as a decimal. So then if we do the inverse here, if we do tangent inverse of that value, we're going to find our angle, which in this case would be 3.434. I'll say as a general rule, these angles tend to be pretty small, right? You know, this is a 6% grade. We saw that airplane one only had, 26 or something percent grade, right? You know, we're not really seeing particularly big numbers here. So definitely keep those decimals attached. Take this out, 2, 3, 4 places maybe, just so you can get some better measurements here. They're all kind of coming into a pretty similar range. So if we just call everything, 3 degrees, we're just not going to get very different answers, honestly. So let's keep some decimals on here. What comes next? So if I know the angle, then I can sort of leverage the angle and the fact that I know the hypotenuse, right, which is my 21,120 feet. I can do SOHCAHTOA setup, right? The sine of the angle should be the opposite over the hypotenuse. So the sine of my 3.434 would be the opposite side, which is my x, my elevation gain, over 21,120. So little crisscross multiply here, 21,120 times the sine value. If I work all this out, that's going to get me to my elevation. It looks like that's going to be 1,265 feet. So, 1,000, a little more than 1,250 feet of elevation. So over 4 miles, right? Again, this is not just sort of straight up climbing. This is doing stuff in chunks. But that's about as close as we could get to sort of what would be a real world problem. If you're sort of driving, up or down a hill, you sort of see this sign, right? If you kind of measure on your odometer how many miles you've gone, you can sort of reverse engineer your elevation gain. We'll pull one from the homework that does some similar stuff, number 17 here. is doing some similar work, driving on a road, 5.9% grade. And we've covered a horizontal distance of 2 miles. So how far have you actually driven? So this is an interesting one, right? We're talking about now, given the horizontal distance, this sort of like tunneling distance, right? As if we were in, again, some sort of like mole man, kind of like a tunneling machine going directly into the hill. We've gone 2 miles. We're sort of mining, I guess. Or we sort of get this mining measurement. So the question is, okay, well, driving on the hill, right, actually up on top, this hypotenuse, how far did we actually drive? What would our sort of odometer say? So let's compare these two together. This is going to have a similar kind of steps to the one we just did, the example from the book, but we're searching for slightly different information. We're sort of working this a different way. So our percent grade, 5.9%. We can find the angle first. I've got a picture. It always helps to draw pictures to go with these. So I need the angle here. I know this distance is 2 miles. That's sort of my adjacent. I'm trying to find my driving distance, right? So that's up on top. That's this hypotenuse. So if I can get the angle, that'll be something I can work with. So tangent of the angle here would be 5.9 over 100, right? So that means tangent of the angle here is going to be 0.059. That's just my percentage, right, converted back into a decimal. That's sort of coming from our opposite over the adjacent. That's our sort of percent grade. So if I do tangent inverse of that value, what's my angle? 3.38 degrees. We've sort of seen a lot of 3-ish degree angles here. So again, keep those decimals on so we can get a semi-decent number. So redrawing this information. So if this is a 3.38 degree angle, trying to find my x value here, which is my hypotenuse, what do I know? Well, I know the adjacent value, my horizontal distance here is 2 miles. So the cosine, right? So what trig function is going to connect my adjacent and my hypotenuse? So that would be cosine. So cosine of 3.38 degrees should be 2 miles divided by this x value. The cosine value, we're just running it straight from the calculator, essentially. So 0.998. You're going to be extremely tempted to just call that 1. But if you call it 1, then you're not really going to get any difference in your distances, are you? So ignore that impulse, even though it's sitting right there. There's some sort of incline. So we have to use numbers that will get some sort of different values here, right? It's not just going to be 2 miles to 2 miles. A little cross multiply sort of right to get to this x. The x is on the bottom, so I got to bring this over and then divide by the 0.998. That's going to get me just a little bit of a longer value. In this case, 2.003 miles. Again, measuring in miles, these numbers are pretty close together. If we did feet, you'd see a little bit more of a difference here. But in some sense, right, the idea is this is not a super steep situation necessarily. So our horizontal and our driven distance, our sort of hypotenuse distance, not too far apart. Obviously, over sort of longer and longer distances, you're going to see a bigger separation. So everything here is all about the numbers. Or if we use smaller units like feet, or nobody would ever want to do this, but if you'd measured it in inches, you would get very different numbers. But you'd also get very big numbers. So let's not do that. That sounds terrible. Anyway, that's the end of skill 16 using this sort of angle of elevation, all this percent grade stuff. There you go. Driving over the hills, getting some measurements.